Hello and welcome to my Advanced Fabrication Machines presentation. Originally I gave this presentation at MomoCon 2022, and had I had the foresight, I would have actually recorded that presentation. But instead, I'm going to give the presentation again in front of my computer instead of a crowd of fans. Alright, so let us get into this. What are we going to talk about? We're going to talk about a variety of machines, some of which you might be interested in purchasing, some of which you probably won't be. However, the internet is fantastic and has made access to these machines available via various sites. There's tons for 3D printed content. You can also use Xometry. You can get milling work done on Xometry. But the key is that it's great to have an idea of what these machines can do, what their benefits are, how they work, and what kinds of work are best done by what machine. So we'll discuss how the machines function, the process of going from an idea to a model to some kind of file that you can either give to the machine or give to someone else who's going to run it through their machine. We'll give some examples of work that I've done using these machines, and then we'll give some examples of specific machines in case you're actually interested in purchasing some of these monsters. Who am I? I'm Les. I am a software architect here in Atlanta. And as a hobby, I make a lot of stuff, a whole lot of stuff. So I've done everything from hot stamps in brass, milled on my milling machine, hidden closets, escape room props, etched glass work, leather work, work on t-shirts, you name it, I've probably done it. So what are the machine classes that we're going to talk about today? We'll talk about two-dimensional cutters. That would be our laser cutters, our vinyl cutters, and our Waterjet cutters. We'll talk about our 3D printers. 3D printers we'll probably spend the least time on because 3D printers have the most exposure. There's tons of content available explaining how 3D printers work and the best things to use them for. 2.5 dimension cutters, these are going to be our milling machines. And we'll also briefly touch on industrial sewing machines because a lot of people seem to think they need one. All right, first up is laser cutters. This is a Glowforge. This is actually a laser cutter that I own. Well, not this specific picture because Glowforge takes better pictures than I do. Okay, how do laser cutters work? You have some kind of laser that's focused by a head, and it cuts a piece of material. Now, there's a variety of materials you can cut, and in addition to the laser doing its work, once the laser has blasted the material, ideally you would like to clear that material out of the work area, because if the laser is spending all of its time cutting essentially the dust, then you're not actually cutting on the workpiece. So you will have an assist gas. Now for your hobbyist, the assist gas is basically going to be air. It's either provided by a fan or air compressor located inside the machines. If you have a bigger machine, there might be an external air compressor giving assist gas. But yeah, so that's it, really straightforward. Make thing hot, make it burn, make it evaporate, have an exhaust fan that sucks all the mess out, and you make a design. There's a couple of kinds of laser cutters you'll run into if you're searching for them. There's galvo fibers, and then there's the actual CO2 gas tubes, like the Glowforge on the right. Now, these are very, very different machines, and they do very different things. On the left, the galvo fiber lasers, they are specifically for marking metal. That's most of what they do. That's great if you're a knife maker, and you want to put your maker's mark on all your knives. It's not so great if you have a piece of plastic, and you actually want to cut through it. The gas lasers, on the other hand, they're great for cutting organic materials. So acrylics, which is plexiglass, wood, leather, those sorts of materials, they're great at working at that. So in general, as a hobbyist, you're probably going to want a CO2 gas laser. Now, there's another class of laser, which is the diode laser. We're not really going to get into that too much. Diode lasers, instead of having a big fragile glass tube, they get their laser energy from a diode, basically a really, really high power fancy LED, you can think of it like. Those machines tend to be really cheap, which is great, but they also are mainly for engraving, etching, not so much cutting. And the materials they work on are a little bit different because the wavelength of light they put out is a little bit shorter than you'd get from a gas tube. Actually, it's a lot shorter than you get from gas tubes. It's a little bit shorter than what you get from the galvo fibers. The basic process of going from idea to actually using the machine, so you're going to design it, and let's briefly mention the difference between a raster file and a vector file. So raster file are the images that you're really familiar with, JPEGs, PNGs, bitmaps. These files represent their data by individual dots of color. So it'd be like red, 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 blue, white, black, like just individual dots of color. That's great if you're printing off on something like an inkjet printer, where the printer is putting red, 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 black, white dots of color on the paper. However, if you're a machine that needs to actually follow a curve to cut it out, you don't want individual dots. What you want is an instruction of how to follow the curve. You want to say, I want a circle that's 4 inches across, or I want a line that goes from here to here. Those files that contain the instructions are vector files. So the most common ones are DXF and SVG. SVG is probably the one that a lot of people have seen. You see it on the web. It stands for scalar vector graphic. So if you are cutting with a laser cutter, that needs to be in a vector format, which is going to be your DXF or your SVGs. Adobe Illustrator is the program that a lot of people are familiar with. It works almost exclusively in vectors. If you want to engrave something or etch something like an image, you can use a bitmap image with the laser cutter. Essentially what the cutter is going to do, it's going to look at the image and say, if there's a solid black pixel, I'm going to crank the laser to full power. If there's a white pixel, I'll turn the laser off. And if there's a gray pixel, I'll do some level of power in between. And that gives you some contrast in the image. If you want to do both, obviously you'll need both. If you are using something like a Glowforge, it has its own website-based software for configuring it and setting it up. So you would take your file you take either your DXS or SVG file, or if you're engraving, your PNG, bitmap, JPEG, whatever, and you'd run it through their web service, which is great. Or if you're using a different kind of machine, slightly more industrial machine, there's going to be some other type of external software package that you're going to run on a computer, and Lightburn is by far and away the most common. A lot of laser cutters actually have controllers specifically certified as being compatible with Lightburn. Some people at the convention asked, how complicated is Lightburn as opposed to something like Cura or one of the other slicer programs you'd use for a 3D printer? The answer is a little bit complicated, but basically, if all you're trying to do is just take a file you already have and run it through the machine, it's about as complicated, maybe a little bit simpler because there's fewer parameters with the laser. However, Lightburn includes a lot of software if you wanted to design something inside the program. So it's not just configuring the machine, it's also some editing is in there too. Another thing to note, internally, the laser does not make a distinction between etching and cutting. All it knows is I'm moving the head at a certain speed and I'm cutting with a certain power. Generally speaking, etching, you're using less power because you don't want to go all the way through the material, whereas with cutting, you're using a lot of power because you want to cut all the way through. Some examples of some things that you can do with a laser cutter. So here we have a book stand. This is actually a parametric book stand that I designed. Very simple. It's made of 4 individual parts that are lightly hammered together. So there's no glue or any kind of adhesive in the model that you see. The tolerances are really, really tight. With a laser, you can get easily 0.008 of an inch kerf, which is to say when the laser is cutting, it's blowing away only 0.008 of an inch of material. That's human hair diameter size. So you can get really, really, really precise cuts. And with that, you can make the tolerances really, really tight. And in a forgiving material like wood, you can mallet it together. And this doesn't need adhesive or glue. Anything you could possibly want to do with this particular item, it holds together just fine by itself. Here we have another very popular use for laser cutters. This is a piece of acrylic. Acrylic is not to be confused with polycarbonate. If you go to a Home Depot or a Lowe's, they're both going to have these materials present. Acrylic can be laser cut, polycarbonate not so much. Acrylic is brittle. If you try to bend acrylic, it will break and snap. Polycarbonate will not. It will bend and yield. The great thing is for laser cutting is that the acrylic is way cheaper than the polycarbonate. Also, again, the acrylic is also known as plexiglass. The polycarbonate is occasionally referred to as Lexan. So, since we're talking about plastics, we should also talk about compatible materials. You can find large lists of the things that you can and cannot laser cut. Some companies will sell things that are specifically laser compatible. The big things to worry about are, there's several things, but one of the biggest ones that is very common are chlorinated compounds. So PVC is a very, very common material. You do not want to put that on a laser cutter. Essentially anything with chlorine you want to avoid putting in the laser cutter. The laser is putting a tremendous amount of energy in a very small space. And when you dump lots of energy, in this case heat, in a small space, you get a chemical party, and almost every kind of reaction you can imagine is going to happen inside the machine. So the chlorine from the PVC is going to form all kinds of strange products, and a lot of those are going to be corrosive. On the plus side, a lot of the things that are actually toxic, you're going to be able to tell because they're going to smell absolutely horrific. You're not going to want to be in the same room with the machine. Now, even if you had the ability to pull all of those nasty fumes out, run them through a scrubber, and safely exhaust them, it's still not something you want to stick in the laser cutter, primarily because the objective lens that your laser is going through, this is the lens that's actually closest to the workpiece, it typically has a lot of coatings on it to enhance its function. Those coatings really do not do well with almost anything. They typically are very, very delicate. Only clean them with certain kinds of non-abrasive cleaners. Be careful what kind of, don't talk bad about them when they're looking. Because of this, you want to make sure that any type of corrosive, say, even if you could pull it out of the machine, you want to make sure it gets nowhere near the objective lens of the laser. And the objective lens is going to be the closest thing to where the beam is hitting the material. So any kind of corrosive gas that may come up, even if you could treat the gas, you still don't want inside the machine. This here was specifically a mount meant for the old style of Oculus sensor camera. You could use it for a lot of other stuff. Specifically, it works for mounting anything 1/4-20 thread base. That's what those holes are for. However, in addition to making really quick, fast mounting brackets, you could also use this for templates, jigs. If you have a sewing pattern and you're tired of dealing with that tissue paper, you could put the design in your laser cutter and cut it out of a piece of acrylic, and now you have something way, way more durable and also transparent. Things that you cut out of the machine can also be stacked. It's a thing that occasionally people forget. So even if your laser cutter is only going to be able to cut, let's say, 1/4 inch thick plywood, let's say that's as thick as wood as it can cut, that doesn't mean that all of your work only has to be a 1/4 inch thick. This triangle maze here is actually several of those 1/4 inch thick sheets stacked up so that you can get thicker, bigger output products from your laser cutter. And they don't have to be the same configuration. You can have dissimilar things stacked on top of each other, and so you can get, like, for instance, you could do a sphere by stacking individual layers of individually cut panels. So those are, and this by the way, this is an escape room prop. All right, so here is something that is super common for people to do with a laser cutter. In fact, at MomoCon in the dealer's room, there were innumerable merchants selling something like this. So here we have a box, and this box is combined using finger joints. So what you have are 6 individual panels cut off the laser cutter that you basically push together. Again, the tolerances on here are really, really tight. So with a few light mallet taps, you can put this together. These particular boxes, my software wisdom cubes that I made, I mean, you could stand on these without issue. There's no adhesive, no glue required for this. So really, really common thing to do. Here, though, on the right-hand side, you can see a zoom in of the must be usable. And you'll notice that there is a discoloration underneath each of the letters. This is because when the laser is cutting, you've got all of these burn products that are in the air, and the exhaust fan is trying to suck them out. However, some of those exhaust products get stuck onto the material, and the reason that these all seem to be on below the letters is because that's the direction the exhaust gases are being pulled. Now, that's not super great. There's a couple ways to deal with this. The real painful one is you could sand it. So the etch here, it has caused these letters to be lower than the surface. So you could lightly sand the surface and get rid of that. A much easier thing to do is actually cover it. So if you buy materials that are specifically for laser cutters, often what they'll have some kind of clear sheet material or sometimes a white sheet material that goes over the actual material. And the idea is the laser will just cut right through that protective cover. And you don't even have to change the settings on the machine. It just blows right through it. However, when the exhaust material goes to stain, it lands on that protective cover instead. And once you finish cutting, you pull the protective cover off. If you actually look at the image on the left, so you see the before software can be reusable, it must be usable, it has the stains. To the left of that, it says software wisdom cube. That has no stains. The only thing that you have to do is just cover the material with something protective. Masking tape works absolutely great. In fact, the cheaper the masking tape, the better. The laser just blows right through it, and any of the exhaust that would stain the material stains the tape instead, and then you just pull the tape off. No problem. Another thing to note, here we're seeing engraving in text, and it looks great. The actual surface that's been engraved is very, very rough. So if you were to look, so here we see the M in must in the right-hand image. If you're actually to zoom in there, you would see that it's really, really rough down there. Sometimes people have this idea of, well, could I use the laser to cut vertical curves by altering the power of the laser? Not really. It doesn't work super well. There's also focusing issues with the laser. So just remember that if you're cutting something with the laser, the actual specific depth that it gets to is extraordinarily hard to control. So it's not something we normally try to do with a laser. Here we have another example. This is a rubber stamp. Specifically, this is a rubber stamp made of low odor rubber. Odor does not refer to the odor of the rubber itself. It refers to the odor of cutting it with a laser cutter, because you're zarching this thing with heat and blasting it out. This actually doesn't smell super bad when you're cutting it. And even though the sections that are engraved are rough, the surface, which is actually what's going to do the stamping, is as smooth as the original material was. And so you get these really, really clean lines with the laser cutter. You can see in the lower right-hand corner what it looks like when the stamp is actually applied. All right, now, I mentioned earlier that your galvo fiber lasers are used for marking metal and that your CO2 lasers can't really do anything with metal. The wavelength that a CO2 laser produces is reflected by metal. Now, you cannot etch the metal, but you can mark it in other ways. So here we have a brass coin, and we have a penny here for scale. The text that you see is not engraved. How this is done is they make commercial sprays, and there's a few do-it-yourself ways you can do this too, but they make commercial sprays that you spray a metal with, and then you laser it. Everywhere the laser touches, the material that you sprayed on melts, and it bonds with the metal. Then when you're done lasering everything, you take it out and you wash it. The areas that were lasered are stuck to the metal, so they will remain. The areas that were not lasered are completely unbound, and so they wash right off. And so that's what you see here. This is a brass coin that was sprayed with this material and then run through the laser. So even though you can't etch the material or cut it with a CO2 laser, you can still mark it. You just have to do some extra work. So here is an example of photo bleaching, or laser bleaching specifically in this case. This is just a plain off-the-shelf paper notebook. Now, a fun fact about most dyes is that a lot of dyes do not do well with heat and light, like lots of it. It breaks the compounds up. That's essentially what's happening here. We're destroying the dye that was used to make this particular piece of paper bluish, which is the original color. So nothing special was done to this. This paper book was put directly into the laser cutter, no preparation in advance, nothing. And this pattern was lasered at pretty low power, because you are dealing with paper here. And you get this really nice high contrast image on it. Here is an example of some of the detail you can get from the laser, and this is also in stone. Now, stone is a material that a CO2 laser can etch. It's absolutely not going to cut it, but it can etch it. So what was done here, the same technique I mentioned where you put a protective material over your substrate, the thing you're cutting or etching, in order to prevent the stains from getting on it, we can do that here and use it as a template. So this is a piece of ceramic tile, like same thing you get from the tile store, and it has this stone look to it. And I took a piece of masking tape and put it over the whole thing. Then I etched this pattern into it. Next, before removing the tape, so the tape is still there. It's been blown away from all the places the laser has touched, but the tape is covering all the other surfaces. Take it out, hit it with a can of gold spray paint. Then let the paint dry, and then come back and remove the masking tape. And you get this really cool looking intricate detail. This is actually a piece of a larger assembly for an escape room prop. Now, sometimes when you've got these really intricate designs, removing the masking tape can be a real pain because the masking tape is now in an intricate design. And where the masking tape is really thin, it wants to break. And now you've got the masking tape is still on there covering up your detail. So you've got to go in there with really small tools and pick it out. It's a pain. In this particular case, this is a commercial, it looks like stone, but this is a commercially produced ceramic tile. These tiles are extremely flat. So remember, we blasted this with a laser. So we blew away the masking tape and we etched the stone. And then we applied our spray paint. So the spray paint is actually ever so slightly beneath the surface of the stone. So what we can do is we can take a razor blade, like a straight razor, and just scrape along the surface of this, and all of the masking tape comes right off, and we don't touch our design underneath, which is pretty awesome. And like I said, this was an escape room prop. It was a very, very popular escape room prop. All right, some examples of these machines. Over on the left, we have the Omtech, the 40RW. That's actually a very, very popular machine. Lots of people start with that as their first hobby laser. Kind of small, 8x12, but it will do a lot in that form factor. The other machines we have here are basically the same class of machine, the 12x20 or, basically 12x20. And you'll notice that the prices vary wildly, from $2,200 for the Omtech to $6,000 for the Mira. And then we got the Glowforge there in the middle. And that's the Glowforge Basic. That's the cheapest Glowforge that you can get. What you're really paying for is software and support. So for the Glowforge, you're paying for their extra fancy features. You're paying for their online service that they have to help you work with your designs and work with the laser cutter in what's supposed to be a user-friendly manner. If you are willing to deal with things like light burn, if you don't mind having a separate computer where you're using it to control the laser cutter, some of the cheaper laser cutters that are compatible with light burn might be for you. Otherwise, if you want to stick to a very large consumer base unit with a good support staff and email, you could go with something like the Glowforge. Something about the Glowforge, though, there's certain features of the Glowforge, given that I own one, they have a feature where you're supposed to be able to just draw on a piece of material and then put it in the machine. The machine will see the drawing, and then it will cut that drawing out for you. I have never really gotten that to work very well. You typically have to have really thick, dark lines for the camera to pick it up, and the parallax is pretty bad, which is to say the camera inside the Glowforge has essentially a fisheye lens on it so that you can see the whole base of the machine. But the parallax correction doesn't work super great, and so what comes out doesn't quite match up what you actually had. Now, for certain work, that doesn't matter. That's fine, which is great because that gives you the option to cut things in the machine without actually having to understand how to use any software at all, other than the stuff that Glowforge provides. So you don't have to worry about Illustrator or anything like that. But if you're trying to get precise dimensions or specific tolerances, it's not super great. So if those are features you're interested in, the specific proprietary features of a particular machine, check out the forums, look at what's there, see what's going on, and see if that's something you're interested in. This is also another point to make. Just because a machine has superior specifications to another, and let's say it's legit, let's say it's not just marketing, and this machine is on paper better than the competition for the same price point, you might choose a more popular machine instead, because the more popular machines are going to have a lot more community engagement, and the odds that someone has already run into your problem and has posted a solution are going to be greater. I once had a 3D printer that by every imaginable objective metric was superior to everything else that was commonly out there at the time. I regret it because I think only 100 people had actually bought this commercial machine. And because of that, when you run into problems, there's not much of a community to help you. You're having to get support from the original vendor, and they may or may not be that supportive. But if there's thousands or tens of thousands of internet users that are there to help, it's actually worth consideration. It is worth considering getting a machine that on paper is inferior if the community is there for it.